When sunlight filters through the window of the Byrne Patent Office and falls on the stack of manuscripts on the desk, a young man with round-rimmed glasses is bowed in thought. Occasionally writing a few lines of scribbled formulas on the paper, this is Albert Einstein, one of the greatest scientists of the 20th century, who redefined humanity's understanding of time, space, energy, and gravity with his groundbreaking theories. Unlike Newton, who built the grand edifice of classical mechanics, or Marie Curie, who explored the mysteries of radioactivity in the laboratory, he used thought experiments as a weapon to uncover the hidden laws of the universe through pure logical deduction. From the small office in Bern to the quiet study in Princeton, from the birth of the special theory of relativity to the ethical contemplation of the atomic bomb, Einstein tells the eternal journey of humanity's pursuit of truth through reason with every thought, every formula, and every voice. At the age of 16, Einstein wrote his first scientific paper on the state of the ether in a magnetic field. Although it was immature, it already showed his independent thinking on the ether, a hot topic in physics at that time. Later, he experienced failure in the college entrance examination and studied at the Swiss Federal Institute of Technology in Zurich. There, he skipped basic courses, focused on classical physics and philosophical works, and formed a deep friendship with his classmate Marcel Grossmann later. Grossmann's mathematical help became the key to his creation of the general theory of relativity. After graduation, due to his rebellious personality and unwillingness to cater to academic authorities, he failed to obtain a teaching position and instead entered the Bern Patent Office as a third-class technical expert. This seemingly ordinary job became the golden period of Einstein's scientific career. Although the work at the patent office was trivial, it gave him plenty of free time to think about physical problems. He often conducted thought experiments on his way to work and during lunch breaks. What would I see if I chased a beam of light at the speed of light? Can a freely falling person not feel gravity? These seemingly whimsical imaginations eventually gave birth to scientific theories that changed the world. In 1905, the 26-year-old Einstein published 5 papers in Annalen der Physik, covering the photoelectric effect, Brownian motion, special relativity, and other fields. Each paper was enough to shake the physics community, and this year was later called the Annus Mirabilis Miracle Year of Einstein. Einstein's scientific achievements were like a storm sweeping the physics community, completely breaking the framework of classical physics and opening up a new path for modern physics. The special theory of relativity is one of Einstein's most groundbreaking achievements. Before that, Newtonian mechanics held that time and space are absolute, but Maxwell's electromagnetic theory contradicted this view. Based on the principle of constancy of the speed of light and the principle of relativity, Einstein drew a conclusion through rigorous deduction. Time and space are not absolute, but change with the speed of the object's motion. A moving clock slows down time dilation, the length of a moving object shortens length contraction, and there is an equivalent relationship between mass and energy, namely the famous EMC, energy equals mass multiplied by the square of the speed of light. This formula not only reveals the energy source of star luminescence and nuclear reactions, but also becomes the theoretical cornerstone of later nuclear energy utilization, completely changing humanity's understanding of energy and mass. The general theory of relativity is Einstein's major innovation in the theory of gravity. Newton's law of universal gravitation held that gravity is an action at a distance between objects. But Einstein put forward a new view. The essence of gravity is space-time curvature. The more massive an object is, the stronger the curvature of the surrounding space-time, like a depression formed by a heavy object pressing on an elastic mattress. And all surrounding objects move along the curved space-time trajectory, such as the Earth's revolution around the Sunday. In 1919, the British astronomer Arthur Eddington observed that starlight bends when passing the Sunday during a total solar eclipse, perfectly verifying the prediction of the general theory of relativity. Einstein instantly became a world-famous scientific idol, and the general theory of relativity was recognized as the pinnacle of human rational thinking. In addition to relativity, Einstein also made outstanding contributions in other fields. He won the 1921 Nobel Prize in Physics for his research on the photoelectric effect. This discovery explained the phenomenon that light irradiating the metal surface releases electrons, not only promoting the development of quantum mechanics, but also laying the theoretical foundation for the invention of phototubes, solar cells, and digital cameras later. In addition, his research on Brownian motion provided direct evidence for the existence of atoms. His exploration of the unified field theory, although not fully successful, pointed out the direction for later physicists to pursue the grand unified theory. Einstein's greatness lies not only in his scientific achievements, but also in his unique scientific ideas and philosophical thinking, which still influence humanity's understanding of science and the world today. Einstein also emphasized the integration of science and humanities. He was not only a scientist but also widely read philosophical and literary works, and had a deep love for music. He was good at playing the violin. He believed that science provides the method of how to do things, while humanities provide the meaning of why to do things. Science divorced from humanities may bring disasters such as the abuse of atomic bombs, and humanities divorced from science will fall into fantasy. This idea of integration of liberal arts and sciences made him always care deeply about the fate of human society, while paying attention to scientific progress. Einstein's influence has long transcended the field of science and become a cultural symbol spanning eras and regions, profoundly changing the development trajectory of human society. In the cultural field, Einstein became a symbol of wisdom and rebellion. His image of round-rimmed glasses and messy hair is deeply rooted in people's hearts, becoming the pronoun of genius in popular culture. His famous sayings such as imagination is more important than knowledge, and raising a question is often more important than solving a question, have inspired countless people to dare to question and innovate. From movies, books to street art, Einstein's image has been constantly reshaped, becoming a spiritual totem for humanity's pursuit of reason and progress.